Okay, so the second video is about the procedure for the bearing selection. And you have three questions. I would like you to practice on them and follow up the steps as we're doing here. So here we're going to have the first question. It's going to be about the bearing equivalent load procedure we will use to specify the design load. So, sorry, I need to remove the timing here. Okay. Okay, so we're going to use the method which uses specify design load. First for the radial load, when we're going to have the P is equal to the V multiplied by the R, where the P is going to be the radial load itself, the R is the radial load, and the V is the rotation factor, which is going to be 1 for the inner race and 1.2 for the outer race rotation, if the outer race is rotated. Usually the inner race is going to be the one that rotates. So the procedure for the bearing selection is going to be, that's for the radial load only. First, specify the design load of the bearing, and usually going to be called the equivalent load, and the method of determining the equivalent load when the only radial load R is going to be applied will take into account whether that the inner or the outer race is rotated. So this will be equal to the P is equal to the V multiplied by the R. Then determine the minimum acceptable diameter of the shaft that will limit the bore size of the bearing. Step number 3 is select the type of the bearing using table 14.1 as a guide. Then specify the design life of the bearing using table 14.4. Step number 5 is going to be determine the speed factor and the life factor if such table are going to be available for the selected type of the bearings. Otherwise, that's when you're going to use the figure 14 and 12. Otherwise, you can simply calculate the C and the cell number 6 by using the basic dynamic load rating equation, which is going to be the equation 41, 14.3, or the 14.4. Step number 7 is identify the set of the candidate bearings that have the required basic dynamic load rating and the diameter, of course. Number 8 is select the bearing having the most convenient geometry, also considering the cost and availability. Step number 9 is determine the mounting conditions such as the shaft seat diameter and the tolerances, the housing board diameter and tolerances, and the means of locating the bearing axially, and the special needs such as the seals or the shields. So we shall start with the example 14.3 on the bearing selection. That's something similar to the one that you had in the assignment sheet, only the parameters are different. For the one that you have actually on the sheet, I can show you later how we do the calculation for it to make you actually compare your results with mine. So here we have the question number 4, for example, is going to be a single row deep groove ball bearings from the table 14.3 to carry radial load of this one 10,500 plus Q divided by 1,000, where the Q is the last 3 digits of your student number, and thrust load of 3.2 thousand, 3,000, sorry, 3.2 kilonewton plus, of course, Q divided by 1,000. The shaft is rotated at 1111 plus a Q RPM, and the design life is 20,000 hours plus Q is desired. The minimum acceptable diameter for the shaft is 90 millimeters. And while we're going to go with this one, we're also going to work on your design. So you can see that the steps is going to be the same here. We have 30,000, we have 62.82 or 600 RPM. We have here 2,891 Newton for the load, and it's a pure radial load. Design life is given, the bearing is to be mounted on shaft with the minimum acceptable diameter of 37.59 millimeters. So we start with our calculation here. And step number 1 is first the rotation factor V will take the value of 1 if the inner race of the bearing is rotate, and that's what we usually going to have. use 1.2 if the outer race is rotate, but here we have the inner race is the one rotating, and we're going to find the p-value to be 2,891. The minimum acceptable diameter is 37.59 millimeters. Now we're going to calculate the value for the C, which is the same value that we done in the example 14.2 that we covered earlier. So it's going to be 29,668 Newton. Now in the step number 4, we're going to go to table 14.3, and we may choose the 6,211 or the 6,308. But we will find that the 6,308 has a bore which is 40 millimeters, which is larger than the 38.7. More nearly line with the desired shaft size. So actually, sorry for that, I closed the previous document, but it's going to be nice to get back to that so I can show you the table when we're going to select the work. Just bear with me for 1 second, please. I'm going to open the PowerPoint once again. Okay. So, yeah, we're looking at diameter of 40 and the load of 29,600. So we're going to go to the table here and look for the diameters. These are the small one. These are the small one. Now here, we're going to start to have the larger one. We locate the value for the dynamic C. So that's in the kilonewton, that's 16.8. That is the 30.7, which is more than 29.6. So I can choose this one. The diameter is 40, so it's going to be above the minimum value, and I can go with that. Okay, so that's how to find the diameter. Once again, I'm going to show you how we done that. We simply just locate the dynamic C value that we calculated. We will find the value which is above the 29,000. We can see that this is 33, this is 28, but remember that the diameter is going to be one of the main selecting factor. We can get larger, but not smaller than the desired or the recommended diameter, minimum diameter. So we go to the 30.7, which is more than 29.668. And thus the diameter is going to be 40, and the type of the bearing is 6,208. We can go actually for further value if you want. You can have more than the 40 millimeters. And you can see, for example, here I'm going to have 33.2 for the 6,209, and I'm going to have 35,000 for 6,210. So whatever, again, to go larger, this will be too much here, and I will ignore that. And this one is actually fit, but the diameter is going to be 1.5 or 150% the size of the one we had. So we'll try to avoid doing that. Okay, so now we choose this value. We said that the 6,308 is going to be my candidate. Okay, with the 40 millimeter diameter. And wait a second, 29,000. Well, actually, if it was to me, I will choose the 6,208 and not 6,308. Okay, so if it was me, I'll use this one, not that one. But anyway, they selected 308. I will choose 6,208 instead. Well, one of the reasons I'm selecting the smaller one is you will find out that the mass is going to be less. So you can see that the value here is going to be quite different. It's almost half. So the lighter the bearing is, it's going to be better for our work. Okay, anyway, here we continue with that. So we just found the bearings. It's going to be the 6,308 single rod growth ball bearings. Diameter is 40 millimeters. Outside diameter is 90 millimeters. The width is 23 millimeters, and the maximum fillet radius is 1.49. And again, if I get to do selecting the 6 to 8, you can see that here the bow diameter, that's the outside brace diameter. The width is given here. That's in millimeter we're talking about. I can choose the radius of the maximum fillet radius. the minimum shoulder diameter, the maximum passing shoulder, the bearing mass, all can be found from here. I think that something, yeah, we just found everything. So that's how to use the tables, and that will be the answer for the first example we are going to have. Now the same thing is for the question 3 we have here. We have the load, we have the 6,000 hours, 750, calculate the C, and you know the diameter, go to the tables, select your candidates, and that's it. You tell us that these are the specification of the bearing I'm going to use. Okay, so I'm going to stop this video. I'm going to start the other question in your video.